The human brain is a remarkable organ capable of processing vast amounts of information, solving complex problems, and storing memories over a lifetime. Learning and memory are two of the brain's most critical functions, enabling us to acquire new knowledge, recall past experiences, and adapt to an ever-changing world. But have you ever wondered how the brain is able to achieve such extraordinary feats of cognition? A key factor in how our brain functions is the electrical activity that occurs within it, known as brainwaves. Brainwaves are the oscillations of electrical impulses that travel through the brain, and they play a significant role in regulating everything from thoughts and emotions to cognitive abilities like learning and memory. There are several types of brainwaves, each associated with different mental states and functions. These brainwave patterns are typically categorized into 5 primary frequency ranges: delta waves, theta waves, alpha waves, beta waves, and gamma waves. Each frequency is connected to a specific mental state or cognitive function, and certain brainwave states are more conducive to learning and memory retention than others. Understanding how brainwave frequencies influence cognitive processes can provide valuable insights into how to optimize learning and improve memory. Delta waves, which are the slowest brainwaves, ranging from 0.5 to 4 Hz, are primarily associated with deep sleep and the most restorative phases of rest. While delta waves are not directly linked to conscious learning or memory recall, they are crucial for the brain's overall health and function. During deep sleep, the brain consolidates memories, processes emotions, and performs other vital restorative tasks. Without proper sleep and delta wave activity, the brain's ability to retain and recall information is significantly impaired. Theta waves, 4 to 8 Hz, are associated with deep relaxation, creativity, and light sleep. These brainwaves are often seen during daydreaming, meditation, and moments of deep focus. Theta waves are particularly important for learning and memory because they facilitate the brain's ability to absorb and process new information. When the brain is in a theta state, it is more receptive to new ideas and insights, making it easier to learn new material. This state is also linked to improved creative thinking and problem-solving abilities, as well as enhanced emotional processing. Alpha waves, 8 to 14 Hz, are present when the brain is in a relaxed yet alert state, such as during light meditation, reading, or creative thinking. Alpha waves are often associated with a calm mind that is focused, but not overly tense or stressed. Research has shown that when the brain is in an alpha state, it becomes more capable of learning and memory retention. This is because alpha waves help to optimize brain activity, creating an environment that is ideal for encoding and recalling information. Alpha waves are often considered the learning waves because they enhance cognitive function without the mental fatigue that can result from higher frequency beta waves. Beta waves, 14 to 30 Hz, are the dominant brain waves during active thinking, concentration, and problem solving. These waves are associated with high levels of mental engagement and focus, making them essential for tasks that require concentration, logic, and critical thinking. However, while beta waves are necessary for active learning and complex problem solving, they can also be linked to stress and anxiety if they become too dominant. A brain that is overly focused on beta wave activity may experience cognitive overload, making it harder to retain new information or think creatively. Gamma waves, 30 to 100 Hz, are the fastest brain waves and are associated with peak cognitive performance, memory recall, and high-level information processing. Gamma waves are critical for linking information from different parts of the brain and for encoding and retrieving memories. Studies have shown that gamma waves play a key role in learning new concepts, processing sensory information, and creating long-term memories. The synchronization of gamma wave activity across different regions of the brain is essential for complex cognitive functions, such as problem-solving, multitasking, and integrating new information with prior knowledge. So how do brainwave frequencies affect learning and memory in practical terms? One of the most exciting aspects of brainwave research is the phenomenon known as brainwave entrainment. This process involves using external rhythmic stimuli, such as sound frequencies or pulses of light, to synchronize the brain's electrical activity with a desired frequency. By using audio or visual stimuli designed to match specific brainwave frequencies, it is possible to guide the brain into an optimal state for learning, memory retention, and cognitive performance. For example, research has shown that listening to audio tracks with binaural beats or isochronic tones can promote the brain's natural tendency to synchronize with the frequencies that correspond to alpha, beta, theta, or gamma waves. These auditory stimuli can help bring the brain into a state that is ideal for studying, memorizing information, or engaging in creative problem solving. Binaural beats, in particular, are a popular tool for promoting brainwave entrainment, as they involve playing two different frequencies in each ear. The brain then perceives the difference between these frequencies as a beat, which causes the brain waves to synchronize with that beat. For instance, listening to binaural beats at 10 Hz can encourage the brain to enter an alpha state, which is conducive to learning and memory retention. Similarly, isochronic tones are single tones that pulse at specific frequencies, helping to stimulate brainwave activity and induce a desired mental state. These tones can be used to promote relaxation, focus, creativity, or memory recall, depending on the frequency being used. Both binaural beats and isochronic tones are effective tools for harnessing the power of brainwave entrainment and improving cognitive functions related to learning and memory. In addition to external stimuli, the brain's natural brainwave patterns can be influenced by factors such as sleep, stress, and mental state. For example, sufficient sleep, particularly during the deep sleep stages associated with delta waves, is critical for memory consolidation. During sleep, the brain processes and strengthens the memories formed throughout the day, transferring them from short-term to long-term storage. Without adequate sleep, the brain struggles to retain new information, and learning becomes significantly less effective. Likewise, stress can have a detrimental effect on learning and memory. When we experience stress, our brains are often dominated by beta waves, which are linked to heightened alertness, but also anxiety and tension. This can impair our ability to absorb and retain information, as well as hinder our ability to recall memories. On the other hand, techniques like meditation, deep breathing, and mindfulness can help bring the brain into a more relaxed state, encouraging alpha and theta waves that are ideal for learning and memory. The impact of brainwave frequencies on learning and memory has been explored in various studies and research. For instance, a study published in the journal Neuro Report found that listening to audio tracks that stimulate alpha waves led to improved learning and memory retention. Participants who listened to alpha wave promoting sounds performed better on memory tasks than those who did not. Similarly, research on gamma waves has demonstrated that stimulating gamma wave activity can enhance memory recall and increase the speed at which information is processed. In another study, researchers found that brainwave entrainment using theta waves improved participants' ability to learn new languages. The participants who listened to theta frequencies during their language learning sessions showed greater retention of vocabulary and grammatical structures compared to those who did not use brainwave entrainment. In the context of memory, the synchronization of brainwave frequencies across different brain regions is essential for creating and retrieving memories. Gamma waves, in particular, have been linked to the binding of information across the brain, enabling us to integrate sensory experiences and form coherent memories. The more efficiently the brain's different regions can communicate and synchronize, the better we are at encoding, storing, and retrieving memories. Thus, promoting gamma wave activity through brainwave entrainment may enhance both short-term memory and long-term memory formation. By understanding how different brainwave frequencies influence learning and memory, it becomes clear that these mental states play a crucial role in how we acquire, retain, and recall information. Delta waves are important for sleep and memory consolidation. Theta waves foster creativity and learning. Alpha waves create an ideal state for focused attention. Beta waves are necessary for active thinking, and gamma waves enhance memory and information processing. Using brainwave entrainment techniques such as binaural beats and isochronic tones can help harness these natural brainwave frequencies and optimize cognitive performance. Whether you are looking to improve your focus, enhance creativity, or boost memory retention, tuning your brain to the right frequency at the right time can make a significant difference. By incorporating brainwave entrainment into your study routine or cognitive training, you can enhance your ability to learn faster, retain more information, and ultimately improve your cognitive abilities. In this way, understanding and harnessing the power of brainwave frequencies can be a game changer for anyone looking to boost their learning and memory capabilities.